Hi, and welcome to MSc. In today's video, we're going to be looking at naming alkanes. An alkane is an acyclic saturated hydrocarbon. Now, there's a lot to unpack there. Let's start with acyclic. This means that the hydrocarbon, the organic compound composed primarily of carbon and hydrogen, will have no ring structure. It doesn't form a cycle and link back on itself. Another way to say this is that it's a straight chain. And I put straight in quotation marks here because it doesn't actually mean that it's a perfectly straight line, 180 degrees all the way along. I'll talk more about that on the next slide. The saturated piece implies that there's only single bonds connecting the carbon atoms. It's holding as many hydrogen connected to that carbon chain. So you can picture it being saturated. It can't take any more hydrogen. All hydrocarbons meeting this criteria will have an ANE ending. And the ANE ending is going to be common here, and we can see it in the alkane. They're all going to have this ane ending. In my mind, there's 4 steps that we need to consider when we're trying to name alkanes. And these 4 steps will also serve us well as we go on and then start to branch into more and more complex functional groups that can be attached to our hydrocarbon. The first step is to identify the longest straight chain. If we look at this chart, we can see that there's a number of carbon atoms, in the longest chain, and I've listed out 10 here for us. The name or the stem that goes with it is in the adjacent column. So if we look at something that had 3 carbon atoms in its longest chain, this would relate to prop. In this case, it would be propane, because it would be a alkane with single bonds. In the example listed, we have 1, 2, 3, 4, 5, 6 carbons in this straight chain, and that leads us to hex. We're calling it hexane. But there are other ways that this can be drawn. We could also draw it like this. If you remember from previous lessons, each carbon along this chain has 4 electron domains surrounding it and is tetrahedral in shape. So sometimes you'll see this as a bent chain like this. However, that is still what we consider a straight chain. And if you remember also that because these are all single bonds or sigma bonds, we are free to rotate around those single bonds. And so we have to keep in mind that when we say straight chain, it can be drawn like a straight line, but it could also be drawn like this. Furthermore, because it would be tetrahedral, it would actually have a 3-dimensional structure, and you might even see it drawn like that, where it looks like more of a 3-dimensional picture. Additionally, we could even have it drawn like this, where we can look and say that we have 1, 2, 3, 4, 5, 6. This would still be hexane, because remember, we're just sketching this out as a representation, and because we're free to rotate around these bonds, we could have it in weird shapes as such. Typically, we would draw it just as a straight chain, as a straight line. But all of these are all just hexane. They all have 6 carbons with single bonds connecting between them. The second step is going to be to identify and name any side chains. So once we've identified that longest chain, we'll have to look for other carbon atom groups that are branched off of it. And we're going to look at the number of carbons in those groups. And they will again relate to the meth, eth, prop, but, all the way through. Additionally, we will add the stem name with an YL ending. So it wouldn't be meth, it'd be methyl or ethyl or propyl on any of the side chains. The third step is to identify the position of those side chains. And we're going to count the number of carbons along the main chain, that longest chain, that will give us the smallest number overall. Let's look at an example here. Here, if I look at this structure, I will notice I have 4 carbons along this part, and I have 4 carbons descending here. So you might look at quick glance and say, well, this 4 carbons will be but or butyl of some sort, perhaps. But We have to remember that the straight chain or the longest chain doesn't always need to be written in a straight line. So in this case, we have 1, 2, 3, 4, 5, 6. So we're back to that hexane idea. The same example, very similar to the first one I showed you. So we have to remember that when we look for that longest chain, it's not always written just as a straight line. So we have a hexane here. Off of that hexane, I see this group here, which is a single carbon, which is meth. But we don't just say meth, we say methyl, because it is the side chain off of the longer hexane. Additionally, now we want to number the carbons in this longest chain that will result in the smallest numbering on our methyl group. So if we start numbering here, it would be 1, 2, 3, 4, 5, 6. That would be 4 methyl, indicating it's off the 4th carbon. Or 1, 2, 3, 4, 5, 6. That would be 3. So we will name this then in that manner, starting here with 1, 2, 3, 4, 5, 6. And with that in mind, our name here will be 3-methyl hexane. Notice that there's a dash here, a hyphen, between the number and the group. The methyl is the side group, and the hexane is this longest chain, starting with the numbering here, that will result in a 3 here. The 3 indicates the carbon, which the methyl group is bonded to. Again, we have hex because of the 6 carbons here, and we have ane because they're all single bonds. The fourth step that we have to consider is, what if there's multiple chains? So this doesn't always apply, but there can be multiple chains present. When we go to name them then, we put them in alphabetical order. Additionally, if there's multiple of the same type, then we will use the prefixes di, tri, tetra, penta, and so forth to indicate how many there are. So if I had 3 methyl groups on a very long carbon chain, I would say trimethyl. One thing to note here is that the prefixes do not count towards the alpha order. So if there was 2 methyls, it would be di, but that would still come after any type of ethyl group. So dimethyl comes after ethyl because E comes before M. Again, let's look at an example here. This example might seem pretty complex at first, and it is challenging. Let's work through it here together. We're looking for the longest chain. And when we look at that, we can see, well, this straight part across the middle here looks promising, 5 carbons long. But you might look here and be like, well, we also have 5 carbons this way or this way. So here we have to make the best choice we can. Because if I choose this bent part here as my longest chain, I would notice an ethyl group, a methyl group here for 1 carbon. But off of this, I'd have a different other group that would have a branch in and of itself. Whereas if I name this as my longest chain, I see unbranched chains coming off of it. And that'll be the approach that we want to take. So we will name things according to this chain here, which is 5 carbons long. 5 carbons is pentane. Now we can look at the side groups. I'll notice that I have at the top here 2 methyl groups, and they're methyl because they're single carbons. Additionally, I have from the middle carbon here an ethyl group that runs down here. So I'm going to have some type of dimethyl group along with this ethyl. So now we're going to look at the numbering. And because of the symmetry here, it turns out it doesn't really matter. If I number this as number 1, This would be 1, 2, 3, 4, 5. If I number it the other way, it wouldn't change. I'm going to have a 2 and a 4 methyl, and I'm going to have a 3 ethyl in either way. There are some cases where you can number it different ways that will generate the same numbers. In which case, we want the lowest number as the leading number. Otherwise, we're looking for the lowest total number. In more complex examples, in later videos, that part might become a little bit more clear. And as you get more experience with this, you will see more complex examples where things like that might apply. In this case then, we can write the name of this, and I'll start over here to give myself some space. Ethyl comes before methyl. So we're going to start with the 3 ethyl, and then it's 2,4 dimethyl. 2, 4 slash dimethyl, and then it is pentane. So this is 3 ethyl, 2,4 dimethyl pentane. One last thing to note here is that we always separate numbers and letters with a dash, and we separate numbers with a comma. Please note that the last, what we call alkyl group here, that last side chain with the YL ending, does not get a hyphen here. Hyphens are for separating numbers and letters, and commas are for separating numbers. I hope you found this video helpful. Thank you very much for listening, and thank you very much for watching.